Let's see what question we have over here. Given that the HCF of 12, 18 is 6, find the LCM. Okay, so I'm being given the HCF of two numbers and I have to find the LCM. The first question that strikes me when I read this question is, why did you give me the HCF? I already know how to find the LCM if I know both these numbers. I just have to prime factorize 12, write it in its prime factorized form, write 18 in its prime factorized form, take the highest powers of each of those prime factors and I'll get my LCM. That's definitely a way you can do this problem. But because they're giving us the HCF, the question is giving us a clue. Hey, can you try this other method that you know of? There is another way to solve this. It's a shorter way. Are you aware of this? There is a relationship between the HCF and the LCM. Think about that. Can you recollect it? The relationship is this. If you have two numbers, right? This is the HCF of these two numbers, right? And you have to find the LCM of these two numbers. The key term here is two numbers, okay? So if you have the HCF of two numbers, let's say HCF, and then you have the LCM of two numbers, of the same two numbers, of course. And then if you have this other quantity, which is just the product of these two numbers, I'm just going to call it the product of the two numbers. So these three are three quantities, right? HCF, you know how to find. LCM, you know how to find. Product, you've always known how to find. You just have to multiply these two. Then there is a relationship between these. And it's like the HCF into the LCM. The product of the HCF and LCM will be equal to the product of the two numbers. Now pause for a moment. That's beautiful if you think about it. Why this works, if you have a lot of questions around this, we will talk about that in a later video. But just notice that this is actually going to make our problem much simpler, right? So if you believe this to be true, it's in the book. So let's believe for now that this is true. HCF into LCM equals product of the two numbers. Then how will you solve this question? You don't have to prime factorize all this now, because all you'll say is, oh, HCF is given to me. HCF is 6. So that's given. That multiplied by LCM, which is what I need to find, LCM, will be equal to the product of the two numbers. And the two numbers here are 12 and 18. So 12 times 18. And with this, I can find my LCM. I'm going to divide both sides by, that's right, 6. So that I have LCM equals, I divide this side by 6 and then I divide this side by 6. I get 12 times 18 divided by 6. And we can find the answer to that. 6 and 12 would be, this goes like 2 times 6 is 12. So I'm dividing by 6 on the numerator and denominator. And you'll have 18 times 2, which is 36. So the LCM of these two numbers, 12 and 18, is 36. But you didn't do it in the usual method that you're used to. You did it this time using this new property or this new result. So let's this is actually the main point of this video. The main point of this video is to help you know this result, that HCF into LCM equals product of the two numbers. Now what I want to do is really highlight this 2 over here, okay? The key term here is this 2. Because if this had been three numbers, if you had been given the HCF of 12, 18, something else, so all three numbers, the HCF is 6, find the LCM, you cannot do this. HCF into LCM will not be the product of those three numbers. So 2 is really the keyword here. So as long as the question has only two numbers in it, HCF of two numbers, then this result works. Which must raise a question, right? Why is it that that's the result? This looks so beautiful. Only works for two numbers. Think about that. I mean, it's a great question to think about. While you do that, right, one of the best ways to get comfortable thinking about these things is just solve one or two more problems using that. So let's do that. Let's solve one more question where we use this property. Now in this question, I have HCF of two numbers is 11 and the LCM is 693. So both the HCF and the LCM are given to me. One of the numbers is 99. Find the other number. Now, how do you want to think about this question? You just learned a new property. So your mind might be thinking, oh, I can definitely use it. Just before you conclude that, always verify, hey, it is two numbers, so it'll work. If it's 3 or 4 or 5, it won't work. So it's two numbers, so yeah, we can use that property. And what is that property? The HCF multiplied by the LCM will be equal to the product of the two numbers. Maybe for now we can call these two numbers, say, N1 and N2. Just serious sounding names for just the two numbers that we're looking for. So in this question, what they're doing is that they're giving us the HCF and LCM and one of the numbers and asking us for the other number. So you can pause right now, because after this, it's about putting the numbers right in and finding the answer to the number that we want. I'm going to do it now. So HCF is what? HCF is 11. So HCF is 11 multiplied by LCM is 693. 693. One of the numbers is 99. 99. And the other number is what we want. So now I'm just going to call it, N2 maybe. So how do I do this now? I'm going to divide both sides of the equation by 99. So that'll give me N2. N2 equals, I'm just bringing all this here, okay? Or actually I can keep this on this side itself. It doesn't matter, right? So 11 into 693. 11 into 693 divided by 99. 693 divided by the 99 that I divided both sides by. So 99, and maybe we can go left side now. So what happens here? So I know that 11 and 99 are nicely divisible. So this is 9 times 11. So I have this. 9 and 693, it should probably be divisible because we're looking for a natural number. So 69, 9 goes, 7? 9 7s are 63. So 7 times, you have what? 69. So you have 6 remaining, 63 or 77. So there we have it. The other number is 77. I can write it on this side also, 77. And we have it. So this new property, as you can see, is pretty useful. If not for anything else in the real life, at least to answer many questions where we know 3 of these things and we're asked to find one of them. So all the questions you will see, in fact, most of the questions you will see will be where you're given the HCF, LCM and one of the numbers, or LCM and 2 of the numbers, or HCF and 2 of the numbers. That's pretty much the types of questions we can be asked over here. So you don't have to really practice hundreds of questions here, right? Because you know all of the problems are going to be in this format. You just have to find out which of the 3 you have and find the other one. So that's pretty much all we have to cover in this particular property, except one big question, which is, hey, why is this property true? Why does this work? Can we have, oh no, that was a big ink smudge. So why does this property work? And also asking, why does it only work for 2 numbers? Like the same thing has become n into n1 into n2 into n3 into n4 or something. This doesn't work. So why is that the case? And I'm going to cover that in a separate video. Maybe I'll call that a HCF and LCM product visualized or something. The clue for you though, before you watch that video, I want you to think about this. And the clue is that just think about what the HCF really is. So when you prime factorize 2 numbers and find the HCF, what are you really doing? You're picking the minimum powers of each of the prime factors. And in the LCM, you're picking the maximum powers, right? So think about what you're really doing when you're doing that, and then think about what the product is in the same way. Like when you prime factorize the 2 numbers and think about what the product is. And when you think about it, you'll be able to see, oh, so that's why it works in the case of 2 numbers and why it doesn't work in the case of higher numbers.